Hi, welcome to the lab. We are currently in the progress of building a scanner generator library. Today I would like to work on a different facet. So in the last video we worked on a scanner driver which is able to simulate our underlying automaton directly. And I try I would like to work on a table-driven implementation. And then just compare the two implementations which we've done. And not sure what we will find. So I'm thinking that the table-based implementation will be faster, but I think we will see. But before we start with this task, I would like to do some random cleanups. So first of all, I noticed the following. I defined some predicates which return a signed value instead of a Boolean. And I think I will just, and also I think I mixed up I said, for example, that I'm using 32-bit unsigned integer for states, but here you see that I mix them up, and I'm just using, I noticed that, so let's go a step back. I said that in order to communicate errors for this function, this method, that I would like to extend the range. So I think I said something like, I want to represent states by unsigned 32-bit integers, but since some functions might fail, for example, next state, I will then use it to use a bigger range to also include the negative value as an potential error value. But this doesn't really make sense, I noticed, because the universe of states, so U32, already contains an explicit error state. So I don't really have to use a bigger range. So I'm thinking of just fixing those small issues. And also I would like to introduce a couple of type alias for that. So I'm thinking of just using names for my types. So I think it reads a little bit more clear if I'm just returning. Oh, perfect! It's lagging. So I'm just using state for states, and so this is just a Boolean. This is a Boolean. Where am I typing? And so those are also state, and this accepts a token index, returns a token index, token type, I think. And a token type, what am I using here? A 64-bit integer. So maybe let's just use it. Also a 60. Well, I think there should not be so much tokens. So I think we will use a smaller range. So let's use 32-bit signed. This should be enough. But token types must also include negative values, since -2 represents the EOF token, the explicit end of input token, and so I'm calling it EOF here, end of file, but I think it should be end of input, but well, it doesn't really matter. So, and -1 is the explicit error token, so it must be signed. So token type. And so why I'm using signed? 32-bit. I think I will just keep this for now. Or should I just accept a character? Let's see. I think my method getChar returns a... Why does it return a... Oh, I think I can just always return a unsigned 8. So a U8. So a character is just a U8. Since it always returns value. So no need to extend its type. And then I can just use auto here, since we already named the type. So I think this returns a char, and we cast it to a U8. Does it return a char? Yeah, it does. Okay. Okay, so I think this should be fine. So now let's fix a couple of types. So let's just remember them. Oh, well, I could also, well, so stupid, I could also open it here. So let's just look through our values. So did we somewhere store positions? Yeah, we did. So let's use the type state here as well. This is fine. So let's look through the program. So this assignment should work. Oh, of course, this is now a state. So I'm just use auto here. So state should be a, oh well, I thought the IDE shows it like this. So char state, okay, no warning, however. So let's just fix the problems here. So this one returns a state. We have to define them as private. So why doesn't it see this state? I think it must be protected. So protected. Ah yeah, pretty cool. So this one returns a state, this one returns a state, this accepts a U8. This one returns a Boolean, this one returns a Boolean. Oops. State, this one accepts a state and returns a token type. Token type. So I think even though we always return the same type, basically, this documents itself a lot nicer. So this one returns a state. Well, do I have to prefix this now? Sure do. And this one returns a state, accepts a state, and accepts a U8 character. And so states are unsigned. So this one returns the error state. So I'm just returning the error state here. So this is what we also changed. We made this one a state is unsigned, so I won't return -1. But since the error state is included in this type, basically, just returning it here, even though this code is never reached. A little bit more clear. So in this one returns a Boolean, a predicate, so accept a state here. And same here, Boolean, state. And this one is the token type. Token type. And it accepts a state. So I think this should be it. Now we should build again. Let's also, while we added, fix the warnings we generate. So cheers. So, so let's see if our program actually works. Still works. So let's take something in hello. Let's do 42 if and if x. I think so. This looks good on the first glance. So open parentheses. So this looks a little bit weird. Maybe we will put the lexeme in backticks or something in quotes. But hello, white space, literal, or 42, the keyword. So I think our program still, it basically still works as before. So I think I didn't have to copy this. So, okay, sure. So let's do this as a first commit. Use more sensible for states. Type names, types and names. Yeah, sure. So I think I won't explain anything here. What is your problem? Modified since it was first processed. What? Yeah, sure, okay. Okay. So, next up, I would like to do the following thing. So currently, we have a data structure which represents a set of characters. And this character set internally uses a array of booleans. And we allocate enough memory for the whole character range. So for 256 plus 1 characters. I don't know why we use plus 1 here, but one character more or less doesn't really matter. But of course, this data structure should be like, so a Boolean should be a byte, I think. So I think this data structure should be like 256 bytes. Let's double check this. So character set, did I import this? So let's see, what does this print? So yeah, 256. So, but of course, we could also use a much more efficient representation. So we could just use 1 bit to represent a charset, instead using a Boolean. So it would be 8 times less memory. So we only need to consume 32 bits instead of 256 bytes. And I think I would like to work on this next. So, but I'm not really sure how I would like to do this. Since, so of course, so a bit field could fix this, but I think it should be, or should it be dynamically sized or statically sized? That's what I'm thinking about. So a static bitset, and what if we had both? Maybe let's not overthink it. Let's just introduce a new class, which I'm going to call bit field. Yeah, so I'm thinking, is bitset a better name for this? Well, the important decisions. We can always rename it later. So let's say that our bit field is statically sized. So I'm giving it a template parameter, the bitsize. And I think I have to include types. So let's add this to our CMake. I think I don't need a C++ file, since it will be templatized every method. So let's see, bit field. Let's include, so it's for bit field. So let's remove some includes from our test method here. So should we do a separate main for this? Yeah, so I'm just going to include, create a separate main where I'm just going to, let's also import the symbol, our global space. And let's give it a fixed size. So let's maybe say we would like to write 16 bits. Well, I would like this to be possible. So let's add a constructor. Done. So now let's see. So the size is known statically, but what if give it a size which is not divisible by 8? So, or do I would like to store it in? Do I want to store this in 64-bit integer? So it doesn't really matter. Does it matter? No, I think not. So let's 64-bit. Let's store it in 64-bit integer. So let's introduce a member. So, and basically we would like to say something like this. So each unsigned 64-bit integer can store 64 bits. So I think I have to do something like this. To reserve enough memory to store size bits. So then in this example, I would store 16 divided by 64. Integer division should yield 0, 0 plus 1. So I have space for enough bits to save 16 bits. And I actually have more, but it doesn't really matter. So, and what happens if I put here 0? Then we should still allocate 1. And what happens if we request 64 bits? I think then we will allocate 2. Then 64 divided by 64 is 1, plus 1 is 2, but it would also not really matter. Maybe let's start a bigger in a smaller type. So like this. Can I somehow how do we do this? So let's introduce a new variable called count. Let's say the following. Also, instead of naively using this equation, I'm thinking to check if size is actually modulo divisible. So if there's a remainder when dividing, if the size is a multiple of 8, since I'm using 8 bits here. Sure. So if it is a multiple, then we just use the size, else no. Then we don't plus 1 basically. So if size is multiple of 8, we use 0, else we use 1 as additional base. I think we can then just use this. Oh, and this should be an unsigned 64-bit. Oh, I think I'm missing static here. That's not trying. So which type is this? Integer. So let's explicitly say that it's unsigned 64-bit. So I think this should now. So let's do some simple math here. So if I'm requesting like, let's say 8, now let's just say like 5. If I'm requesting 5 bits, then I should, well, let's also print it for size of this. So let's first think it through. So I would expect now, so 5 is not multiple of 8. That's why we should, additional should be 1. And size divided by 8 is 0, since 5 divided by 8 is 0. Yeah, okay, fine. Because it's integer division, and then plus 1 is 1. So I think we would have enough space to store 5 bits. So if I request 8 bits, 8 of course is a multiple of 8, so that we we won't add additional space, and 8 divided by 8 is 1 plus 0 should be 1. So I think this should be good. So I think we should have enough space, but let's actually print it out. So maybe let's do the following. Let's see if we actually have enough space. Let's use some more examples. So let's also do 256. Let's print it. I think we should now see 1, 1, 4, and 30, 32. Ah, yeah, sure. Missing the constructor. So this is what I'm expecting. Perfect. So now let's introduce accessor methods. So I would like to do now I would like to have a way to access a single bit. So let's do set and get maybe. So and we would give it an index, and it won't change the state. Also, we would like to have a setter which sets a given value. Okay. Let's maybe also add a size method, which just returns the statically known size, just for convenience, since our since our collections have a similar API. So maybe like this. So okay. So to access the ith index, what do we have to do? So basically, we have to find the corresponding byte in this array, and then the corresponding bit in this field. So I divided by 8 would give us the byte. Now we have to access the bit. So then the bit should be modulo 8. And then I have to mask it and check if it is the mask itself. So let's just think it through. the mask. Mask is something like in binary, like this. And then if I mask it, so basically if we have a value like this, then this will be 0, but if the same bit is set, then it returns the mask itself. So if it is set, I should get the mask itself back. So this should be it. I think should be fine. But let's also do the following. Let's also do a inbounds check. So inbounds, let's say index. Index is less than size, let's say. And then I can just assert in bounds that I is in bounds. Of course, I also have to include bitset for that. Okay, so and that should be rather similar. First assert that we are in bounds, but then we have to write. So I think I'm doing this as well. And I think this would be a U8. This is already a U8. Okay. So instead of just copying the value out, we are keeping the reference of the value here. And then we have the mask. So how do we set the value? So let's do it naively first. So let's always kill mask. So now we should have unmasked. So now the bit should be unset. So I think not mask. Yeah, so this should basically unmask the index. Is this correct actually? So let's think of an example. So let's say this is our byte. So let's say this is our bitset, bit field. And this one is the byte of the bit field. So let's say this is like, no, not 2. We are in binary. So let's say those are set. And let's say this is the index. So let's say this one is set. So if I mask this, then I get this. So this is the bit pattern of this expression. If I end this one and our bit field, we only get, so we get all bits set back which were not which are not in our mask basically. So this would give us this basically, since this is our mask. So this should be, now we always nuke our value, but now if we would like to set the value, then we would set it back. So we're just ORing the mask back in, but conditionally, only if we would like to have this set. And since this is a reference, this should already have updated our data structure. So I think this, well, a little bit stupid. What is never used? Get? Sure, we're building a class. Get set, and well, the warning is repeated here. So let's just double check if this works. So let's set a bit true. What? Cannot assign to variable byte. What? Why? Oh, I see. I'm an idiot. Can't be const, but hello? Okay, sure. So let's just run it. So now we have a bit set. We have a single. Well, this did not really work, did it? So the value is 0. So So 0 is in bounds, since it's less than 8. Then I is 0. 0 divided by 8 is 0. So we get the first byte back. So the mask is also 0. Is this correct? I think this is not really correct, since I think this should be +1. Should it? Shouldn't it? Since is this correct? So since I would expect mask is 1, and now the value should be set. Our byte is now a 1, of course. But does this now work? So maybe let's draw this out just for me. So bit fiddling is not really my strength, but let's learn together, shall we? I'm just waiting on Krita. So let's see. 1 byte. In this example, we store 1 byte. So 8 bits, 1 byte. So then we have a bit field with 8 slots. So four, 5, 6, 1, 2, 3, 4, 5, 6, 7. Let's do 8 in front. So now this is our byte. get this mask, this first byte. So a mask, yeah, I see. So the mask has to be one bigger, but is this correct? 1, 2, 4, 5, 6. But this doesn't really scale, does it? So this is, my +1 is not correct. So I think I have to construct, so I have to divide this by modulo. So I have to modulo 8 it, and then I have to shift a 1 by this amount. So then I have selected the correct mask. So I think this will work now, and it makes a little bit more sense. So since then so the mask has always 1 bit set, and I'm just moving it by the offset inside of my byte. So I think this should correct now. So, but since now my biggest index I should be able to set is 7. If I set 8, I think I should get a crash, since I asserted that our index is in bounds. So let's try this out. Set and break after each step. So first we set the first value. Now our data should be 1. We set the highest bit. We are 129. This is fine, since the highest bit, okay, the highest bit is set. The highest and the lowest bit. If I try to set the eighth bit, 8th bit, then now we should crash, since, well, the index is out of bounds. Sure. So let's use this for now. So, and now I'm thinking just to replace our character set. So instead of using a Boolean array, I'm just going to include my bitset. So bit field. I'm keeping, I keep to call it bitset. So maybe we should use this name that, and it has the size. Yeah, so now we're using the bit field. And let's fix all compile errors. So we're using set and get, set and contains. So to fix this, we're just going to set index to our value. And to set a value, so this is for a range, it delegates to set. How did we implement contains? Yeah, contains just calls get with the index, which is in this case just a U8. Should be fine. So now our program should build, but it does not. So I think we should have an overload, a non-const overload for get. So actually I hate this with C++. I would somehow like to say that I would basically love to say the compiler, I would like to have a const and a non-const variant. So, and the compiler can do its job and just copy and paste it for me, but I hate that I have to do this myself. So, and this code is horrible. So it shares the same implementation. And to not share, I have to hack. So of course, so I can't call So I think I'm able to do something like this. So I'm just going to say I'm a const reference. So let's say we reinterpret our serves as a const and just call get the const overload. Is this possible? Not really sure. And can I now? So now can I maybe write this a little bit better? Maybe not, but at least I don't have to. At least I don't have to re-implement this now. So let's use const cast, but it should be fine since we are restricting ourselves. So we are not removing const, we're adding const. So this should be fine. So what is our problem now? Well, I hit build 2 times, I think. Now I need a overload for inbounds, a const and a non-const. So this is really stupid. This. Sure. Now it builds. Let's see if it actually works. So, and I hope our tests. Oh. Yeah, I just stupid, aren't I? So we're just using the test main basically. Let's get back to the real main. Let's just run our test cases and see if they actually capture the potential error. Ooh. I think this output looks almost, so it looks like the previous output. Let's try break code. So let's just, instead of returning the real value, let's just return a hack to see if the result actually changes a thing. So let's just I don't know. Let's just return a random value for now. And let's see if our tests fail. So that way, if we have implemented something incorrect, I think the test should cover this. So and they do. So I think we are fine. Okay, sure. So let's commit what we have. We can always fix a problem when we find it. Introduce class bitfield. This class implements a simple fixed that resized bitfield. Nothing more to say. And now our character set. I think we're just committing this. Of course, we could write some tests. Could we do that? We should do that. Well, but we already have tests for character sets, so I'm just ignoring this. So let's say use bitfield in charset. Instead of storing each boolean, a single instead of storing each boolean in a byte, compress the storage, the used space, the usaged by 8 by 8. Instead of storing each boolean in a byte, we compress the space, the required space, by using for bitfield. This class, well, I don't need to say anything. Bitfield is well known, so don't have to say that we store 8 boolean in a single byte. So I think this was a great refactoring. This was required, I think. This was basically all the refactoring I wanted to do. Now, let's work on the actual feature. Close everything. Now, how do we start? I would like to create another implementation of our scanner driver. But I'm not sure what the interface should be like. So, table-driven table scanner driver. Maybe let's first work on a test bed so that we actually can compare the two implementations. So let's work on this first. I think following. So let's use the same boilerplate, and then so I think we need the same code for each case. So of course we have to have the same specification to test both implementations, so that they are actually comparable. And then I'm just passing a different instance of the scanner driver, basically. And this code will change. So let's maybe move this in a separate method. So what does this code actually need? So maybe let's do something like this. Let's introduce a new method calling scanner REPL. This method, I'm moving this code. So, and the scanner REPL, of course, accepts a scanner, and it accepts a mutable one, so a scanner by reference, scanner. And it also requires our grammar for printing tokens. So and then just call scanner REPL, grammar, and scanner. So this should now work. So I haven't changed anything, I just moved it to a function, a method, a procedure. So still works the same, perfect. Now let's do the following thing. Let's do a similar method. No, it's not a method, it's a procedure. And this one, let's call this scanner time. And what we basically doing, we're just going to measure the time we take to scan the whole file. So while scanner has next, scanner next, and we're just going to discard every token we get. We're just going to measure our time. So instead of calling scanner REPL, then calling scanner time with our scanner. What? John? Didn't we call this has next and next? Other naming, the different naming convention. I'm always mixing those up. So like this. This should be fine. Yeah, sure. So now can run this scanner. Let's maybe also give it a file. So let's give it a file path as well. So a file which should be read and then be scanned. Or let's give it just the input. So let's do this. So let's pass in a string view the input. So then the scanner can initialize input. I'm thinking that this is not correct since since initialize takes 2 parameters. So let's double check. First one is the file path. We're just passing in a dummy file name. Well, we can actually use a real file name. So file path. Let's pass in the actual file path. And the input. So the input would be the file contents. So file contents. So we can't read a file, but we are going to build this immediately. So let's do files all, read all. Let's invent an API like this, for example, and then we can just pass in the string view of the file content. So I'm thinking this one has to be heap allocated. So we're just going to construct a view out of our string. So, but of course, this API doesn't exist. And then I'm thinking we have to time how long this needs. So let's do. How do you actually time on Windows? So it must not be really. Don't has to be rocket science. I think I'm thinking we're just getting the current time, but also build a class for that. like this. Like this, maybe. Maybe let's just return it. So this returns a unsigned 64-bit integer in milliseconds, and then we're just going to be able to say debug log. Well, I have all the information. No, I don't have. So let's debug log scanning file path book milliseconds. Let's say file took a millisecond. Okay, sure. So this takes a scanner. So let's work on this example. So first of all, I would like to create a new file. Where do I run my program? Let's find the folder. Here is it. I think I'm running in the root folder. So let's create a new file. Let's not call it test. Let's call it test input. Let's fill it with some garbage. So let's do so maybe that's enough. Maybe let's repeat this a couple of times. So let's maybe do a million lines. Well, so how much lines are missing? 60,000. So I would like to test a million lines. Maybe this is a little bit overkill, but I don't care. A bit too much. Ah, well, should be fine. So how big is our file? It's not big. Okay. So now let's work on reading our file. Let's try to implement this API, which we just invented. So I'm thinking to create a file called files. This is a class with static helper methods for files. Since I'm not thinking of, I don't want to create a file class which allows me writing files. I just want a single method which is just going to read the contents of a whole file. So read all, and it gets a file path as a string view. Okay. So file path, so read all, string, read all, read complete, read entire file, read completely. Maybe this is a better name. So now I'm going to include string and string view. Read completely. Files read completely. Yeah, I think this is okay-ish API. Files. So let's add this class to our build. Files. Files. So let's do this. And then let's fix this. Read completely. This returns a string, static method. How do we communicate errors? Maybe let's just crash for now. So let's implement this method. So namespace core. So how does it work? How do we read files with C++? Include stdio. I know this API a little bit, so I think it's fopen a file. But you need a zero terminated name. Fun. So should I just make a copy and zero terminate this for now? We do this. So this will be hackish. So we include a string builder. So we are just going to string builder zero term. Let's do it like this. So string zero terminated file path, and we're just going to use a new scope. I'm calling this builder just B, and let's B append file path, B append is the zero terminator. And then I'm just saying, well, let's just keep this around, I'm thinking. So string builder, zero terminated file path. So here we are constructing it. But let's call this I'm not sure how to do this. I would like to do this a little elegantly, but can I get a view out of a string builder? ToString. So let's also introduce a way to get a string view. And this one is const. But this one is, of course, unsafe, since the view is only valid as long as the string builder is alive and you did not call toString. So and in this case, so our string builder has inline storage. So this we have to handle. So in this case, we are just I think you can always return this. Don't have to special handle this, since how does it work? So the inline storage. So our member data is initialized by our inline storage. So we can just always run this. So, and of course, this is highly unsafe, but in this case, we don't need to allocate anything. So this one is string builder. Let's call this file path builder. Give it a shorter name. And then we have a string view, which is called 0 terminated file path. Yeah, I think I would like to do this way. So now I can assign this with toView. But now the 0 terminator is included in the file. So I'm thinking to just reduce the size by 1. So let's just call this one view. View maybe. So now let's construct a string view which points to pathView data, but pathView size -1 to exclude the 0 terminator. And let's call this. Okay, sure. So now I can call fopen, file name, and the restrict mode. Okay, so the file name is 0 terminated file path dot data. This one is now 0 terminated, and the mode is I would like to read this as binary. So what does fopen return? It returns a file star. So if file is null, then we return a null string. Let's just assert that our file exists. For now, of course, this is not perfect. Or should I already create a better API? Now let's just assert it. So now we have a file. Now we can read. So fread, how do you work? Fread. So maybe I have to find out the name, the size of the file, so that I can allocate a buffer for it. So how do you do this? So ftell, I think. Ftell returns the name of a file. So f tell and f seek. Yeah. So f seek. Just f seek to the end somehow, I think. So let's learn some C APIs, shall we? So f tell. The current position, perfect. Now can I just f read? No, f read. And there are constants, I think. So you can somehow, yeah, this is exactly what we're going to do. F seek the end. File seek end. What is the error? Parameters. The total number of elements. Oh, so this is f read. So this is not what I'm looking for. I'm looking for f. So f seek the end of file. Yeah, sure. Okay. What does it return? Return value. If successful, the function returns 0. Otherwise, non-successful. So this is the error case. Assert fc. So in this case, we are asserting a non-zero, but I have to negate this. So then we are at the end. Then we can read the position. This is the we're using binary streams. This is the number of bytes from the beginning of the file. So file size bytes. So is there an error value? On failure, -1 is returned. So let's assert that file size is non-negative. Yeah, sure. And then I can fseek back to the beginning, seek begin, seek start. How is it called? Seek set beginning of file. Perfect. Then I can just, so now I have the size. Now I can f read. So what is the difference between f read? What does actually, we have to free the memory itself, myself. So in this example, it doesn't just uses f close. So we are also doing this. No, we don't need to close free it. So closing this at the end. What is the error code for that? F open and f close. If successful, 0 is returned. So and here we are going to read the file. So f read. Now what is f read s? Where does this come from? Is this just my computer? Don't know what this is. So just f read. So we give it a pointer. This is the pointer to a block of memory. This is enough size, have enough size with at least size times count element. So our size, I think size is 1 and count is, yeah, okay, I know what happens. So you can also swap it. Pointer, size, count, stream, okay. So a block of memory. Can I just cheat and for the string builder? I can't give it an initial capacity. Since it has initial capacity, I think we can just abuse this. So is there a way? So we have initial capacity of this. So let's say we have a way to give this one a initial capacity. So let's extend this class. So we give it a initial capacity. And we default this by, I reference this constant. I can. Yeah, let's implement this. Let's see. So we're always using the inline capacity first, but if our initial capacity already exceeds the inline capacity, we will just allocating some. And I think I can just use this method. So this is just a helper method, private helper, but I can say something like initial cap. I can just call this method, I think, always. So it is bigger as capacity. So I think this will work. So and then, so I'm just abusing this class to allocate memory for me. Then I create accessors for the data for the current state. And the size and the capacity. And our capacity. So now I think we should be able to just create a new result buffer with some space. So let's just say, so in the initial capacity, we can now use the file size in bytes. So and now we can use fread to directly read into our buffer. So file size dot data, we want to write right there. The elements have size 1. We want to read file size bytes elements, and we want to read from file. So, and then we have to check, let's assert that we actually read enough bytes. So, and then at the end, we're just going to close this. But I think we crash, so we don't need to do anything fancy and fclose in any error case. So yeah, I think this is fine for now. So then, of course, I'm just going to return result buffer to string. So now we should only have one allocation. We directly read into our string builder, and we then just return our string and release the memory. And of course, we also remove our temporary zero terminated file path. Okay, so now the first part of our puzzle should be complete. Does this actually work? So let's see. Just going to comment out timer code since it won't compile. I'm just going to call this. Oh, yeah, sure, the file path. Yeah. So let's pass this in. Well, the file path is how did I call the file? It should be called like test input. Yeah. So let's see if this works. Let's see if we reach this method. So first we should create a zero terminated file path. Does this work? Fuck this. But in the next step we should reduce the size by 1 so that the zero terminator is not included. So this worked. So let's open the file and we get a file back. So this one doesn't crash. We should be able to seek at the end that many bytes is correct. So the same number. So then we should be able, oh, this is correct. Then we seek back, construct a result buffer. We read enough elements. So this number corresponds with this number. So they are the same. So this result won't crash. We should be able to close our file and we just return it. So now we have the contents of the file as a string. This looks about right. The size is not set. I see. My string builder did not really work. So let's do this a little bit differently then. So let's revert the change with the initial capacity, since I don't really like that we expose this. So let's just roll back a bit. So we default our constructor. So I could also do this by using git, but not as many changes are involved. So now our string builder should be reset. So now does f read somehow the number of elements successfully read. F arrow and F EOF. So how do you do this? So let's create a result buffer and let's read into a temporary buffer. So give it some size. And now so what does this method return? FEOF. Returns a non-zero value. We are at the end of file. Okay, so while we are not at the end of file, then we read buffer elements. So then we just, following the F read into our buffer, change this to size of buffer from our file, and this returns count. So rename this to count, and now let's result buffer append. Yeah, okay, sure. Now we can create a temporary string view which points to buffer and has the size count. I think I have to cast this since our string view wants a unsigned thing. So what is your problem now? So, well, I think it's ambiguous. So maybe like this. So now the size should be set accordingly. So previously I was directly reading into the string buffer, but I had to update the size, but I didn't do this. So we're using string views. Now I do it like this, so that we always read into a buffer first and then append it to our string builder. I think this should work now, and I think we also should have the correct size now. The string should have the correct size now. We return a file with the correct size. Perfect. Oh. So this was the first step. Now comes the second step. I think we should also turn this into some changes. So toView is new. Use this method. First, this change first. So introduce a string builder toView. This method returns to a temporary view of the string builder's current result. The view is valid as long as didn't so when does it get invalidated? It gets invalidated if you append something, or if you call toString, or if you destruct your string builder. Didn't nothing else was can be string builder. Well, this doesn't look as okay. Nothing else was appended. String builder instance was not destroyed. And string builder toString. Well, actually, I think calling toString retains the instance. No, let's just be sure here. So, and string builder toString wasn't called. So this is just for temporary reading. For reading the intermediate result. So, and then our little helper class for reading files. A collection. Well, this class adds a static method for files read completely, which reads a complete file into a core string. So then let's introduce a class timer, maybe stopwatch. We have to start and stop it manually. And let's do the usual boilerplate. Stopwatch. Import the symbol into the global space and the IDE lags. So let's model the API we used here. So we would like to create a timer, would like to start it, and we'd like to maybe stop it or just read the current elapsed time. Okay. So let's include core timer. I think we have to also, so it's not called timer, it's called stopwatch. We have to add it to our CMake. Stopwatch.h also. Stopwatch.hpp. So, and I think we're just going to include types so that we have our fancy U64 type. So, start. So then we have a start method and a method to get the current elapsed milliseconds. I think it should not change the class's state. So how do you measure the time? So it doesn't have to be 1,000,000% precise. So I think there's an API in red. So current time. So how does it work? STD, this thread, I think. No, not here. Isn't it here? So put it in chrono. Okay. Let's use this then. And can I somehow get this returns a time point, chrono time point. Can I somehow get the duration since epoch? I want this, yeah. So this one is a time point, and I want time point since epoch. Now I get a duration since epoch. Then I can use chrono cast. No, duration cast, and I would like to, for now, return it as milliseconds. I would like to cast this one. Okay, so now, why doesn't it work? Yeah, I need .count. So can I, using namespace std chrono in here, just locally, I think it reads a little bit nicer. And this one is static. So, and if I start my clock, I'm just going to assign current time to start. If I return the elapsed milliseconds, I'm just going to return start well. You can also remember if we actually started. So if we are already started, well, let's just crash assert and started. Already started. So, and we have to assert not started, not AMD. So assert. So let's also include the assert. And to read the current time, we're just going to also assert not started yet. We assert that we are actually started, and then we can just return the current time minus our start time. So now my API should basically exist, except that this one is now called stopwatch. So does this build now? So let's just run it and see if it actually prints this. Just something. Maybe let's just commit in the meantime. Or maybe 1 million lines is a little bit too much. A simple class to stop a time. A simple class to stop a time. A time span. Measure time span. Measure a time span. Time spans. So what did we do wrong? Start. Not started yet. Oh, I stupid. Oh, and all the time was just reading the file. That is slow. Just 36 megabytes. Can we somehow make this faster? So this one is horribly slow. Horribly slow. What if I just increase the buffer? Or should I just swap this? No, I can't. So what does Google say? Why is fread slow? What did I do wrong? Go down. So I could also just mmap the memory. But it should be fine. It should be fine. So what did I do wrong? Know that just swap this and this pointer, those values. So since we are reading bytes, just say that we want to read a single element has this size, and we want to read one element. But then I won't get the correct number of bytes that we actually read. So what happens if we just increase our buffer? So reading the file is the bottleneck. I wouldn't have expected this. I might be doing something wrong. So milliseconds, so 1 minute. Scanning the whole file took 1 minute. So let's just, so this was of course cold, but let's remember what we measured. Yeah, let's put it behind this. So let's see if we can make this faster by not relying on searching. So currently we are measuring a scanner driver implementation, which in its implementation to find the next state has to search in a list of our underlying data structure. This was just to get something going. I'm thinking that I just keep this implementation. It's slow, but it's trivial, so I think it just must be correct. So if I create a new implementation, I can always test against this one, maybe even automatically. But I think we are not doing this now. So, but now I would like to introduce a new class. So basically a new implementation. So let's just table scanner driver. Let's call it, let's just give it a name. So let's see, this one is an implementation of our scanner driver. So let's include it, and it will also be a final implementation, I think. And let's also add it to our build. Table scanner driver. Well, I'm not really sure if I like this name. So what is your problem? I think you're crying about I have to implement some methods. Yeah, sure. And let's mark them with no discard. And let's also say they are final. So, and our table scanner driver. How will this class work? I think, so we have to construct of this class somehow. So I think we just create the tables. So how could this be achieved? So I think we will introduce a private constructor which we will fill out. So I don't know how many arguments it requires, but I think I would like to have a public method that I need options, since the creation of this can fail, I think. Yeah, because we have to allocate memory and this can fail. Oh, but maybe we just crash for now. And I think we just going to accept a DFA. So a DFA. Option for error handling. So, and of course we have some private state. So let's see what we actually need. So we have to remember the start state and the error state. And I think we are just going to pass those in. Start state and the error state. Of course, we have to remember those. So start state, error state. Come on. I don't know why this is so laggy today. I hope my camera is fine. Well, doesn't really matter. So, and how could I answer this? So I think those two methods could be implemented in terms of each other. So but let's do the following. So we learned a thing. I would like to disallow copying. So let's just start by marking the copy constructor as deleted, but the move constructor as default. Come on. And similar the move and the copy assignment operators. Operator. Okay, sure. So let's see. So okay, so now we have to build basically a table. How does it work? So we remember those two. So those are basically done. We can just return the numbers here. So let's do this. Start state, error state, done. So now next state. How do we find out that the state is an accepting state? So I think is error state, we can just, since we know how this data structure explicitly contains a single error state, and we know this state, so we can just compare this. So if our error state is the same as the state we pass in, so this one is done as well. How do we get the accepting token? So I think we have to extract this information out of this. So I think we might need a list of accepting tokens. So I think, so this is a list, and I'm thinking we are using this list to map from a state, which is basically a unsigned 32-bit integer. We map a state ID to a token type, which is signed, and I think we can just look it up in this list. I think we can just, so we have to fill this list, of course. So we're just going to return accepting dot, not dot, but just return the value. So, and of course, list will, if this index is invalid, the list will assert. So, and to find out if we are accepting, I'm thinking that the token types, how do we encode those? So we have the -1 is the error token. So I'm thinking we have to default to -1. So we default to -1. Every value is defaulted to -1. And if I'm accepting, if this state well, I would want to paste this. State is accepting state of state returns the token index. So I think we can, if we model this like this, we can just, to answer if we are accepting, we can just accepting token of state, and if this is non-negative, since accepting token returns the token type, which we default to -1, this means we don't accept, but that mistyped accepting, of course. But if our state is accepting, then we write correct accepting token type inside of the list. I think then we should only have to deal with this method. Of course, I have to remember which state is accepting. So and how do we deal with the transitions? Do we want to directly allocate memory? No, let's just also use lists. So, and I'm thinking that we'll use a list of state, which is called like transitions. And here we will also map to, we'll also have a default value, but we default to error state. So this is the nodes that we have to implement later, of course. And here, and basically m transitions of state and character returns the next state, or something like this. So then let's also add this list to our constructor. And yeah, well, let's implement it. So the constructor, we have to implement 3 methods. We have to implement create, constructor, and next state, which I'm not going to implement inline, I think. So let's remove every method stub which previously generated. For next state we have to implement, also did those. So let's begin with the constructor, then let's create and maybe let's open the namespace at the beginning. So one quick pause, I have to go to the toilet. Oh, hi, I'm back. Let's see. Let's start by working on the. Oh no, I just opened the namespace. So let's just remove this everywhere in this file. Don't have to prefix it. So then let's remember everything we know. So the constructor is really trivial. Just have to remember every data we pass in, and of course we have to create it later. But let's start by implementing the. So, and we're just std moving the list in. And now the accepting, and it lags accepting. Okay, sure, perfect. So this method, so I think we will work on this and this in parallel so that, well, the state table, that we know how to read our state table. So, but now we want to work on the following. We would like to, instead of give our scan time method this instance, would like to give it a table scanner driver create like this. Oh, and of course I have to include this. So does this build? So this builds, but of course we have to implement something before we actually are able to run this. So let's see. So I think let's just work on creating our automaton. Oh, can we actually forward declare this? I think we can. So do this for once. Let's ignore this. So we should already have included this wherever we consume this API. So to create a driver, what do we have to do? So we have to find the start state. So basically we have to fill out those values. So let's copy them here. And I drop this suffix, this prefix. Also here. It reads a little bit cleaner now. Yeah, so now to fill out those values. So the start state, I think we get it by just asking our DFA start state. This returns a pointer, and in our case, we require that it is not null. So we just, we just access it. So if it is null, if this automaton doesn't have a start state, this will crash, of course. So this just instead of asserting, and I think the error state will calculate very similarly. So this method doesn't exist, so let's create it. So error state. Oh, and this is error. So we should only have one error state, and if not, we will crash. So now we have those informations we already have. Let's say error state. Okay, sure. So then let's initialize our lists. So how many accepting states? So how many elements do we want to write in this list? Well, we have to remember for each state if it is accepting and which token it accepts. So accepting will have token count elements. So no, not token count, state count. So, and I think list has an initial capacity. So we're just serving as many elements as we need so that we don't have to allocate more than we need. And the transitions, how many transitions are there? Well, let's actually see. Let's just use this as a scratch to scribble something. So if we have a table, I would like to create a table like this, and on this axis we have every character. So we have 256 characters. Where is the thing? Yeah. So characters, and on this on this axis we have all the states. So we have to reserve 256 by state count spaces, so cells basically. And we're then just converting the index to the 2D index to a single dimension basically. So let's see. We have star count, have so like 256 characters, and we have transition count, have state count times char count transitions. So, and then I can just initialize this with the correct count. So in the end, then we do some to-do. In the end, we are just table driver start state, error state, SAD move transitions, and SAD move accepting. Okay, so now we have to only fill out this and this list. So let's start by filling out the accepting states. I think this is really easy. So we're just looping through our states. So DFR states, and if of course we have to accepting. No. So accepting is a list. So we access it with the states ID, and we fill this with our error token. And then if our state is accepting, we overwrite the value with the token index. Or maybe I should create a constant for that. So for -1, so for those special tokens, basically. So let's say so we have EOF and we have error token, and I'm just going to remember them the S32-bit, signed 32-bit, and of course EOF then is -2. Come on, the error is -1, and instead of hard coding them like this, just going to special token type error like this. So, and where did I use the -1? The -1 was error. I use it somewhere else. No, I use -2 somewhere. So error was UF -2. That should be it. Another appearance? No. So now I have constants for this. And now I can also put this here. So we return the error token type. Yeah. So can I write this a little bit shorter? A little bit short? A bit shorter, yeah, I think how you say it. So like this. No, I don't like this. Or let's actually keep it. So we're defaulting to the error token type, and then we override it for this token index is assigned. I think we can just use token index. This is the token type. We just use S32 here. So this table should be ready. This should be it. So now how do we handle the transitions? I think we should, for this, so this case we iterate over our arcs, I think, since the transition information on the arc struct. Then, so we know that arc.source origin is the one state and target the other one, and the arc data structure links origin and target. So, but how do we do this? So state. So I have a character set. So a charset is, I think, this method. I have repeated this loop everywhere. So let's just repeat it one more time and clean up later. So we loop through all characters and we just skip those who are not on the current arc. So charset contains, let's call this one C, we skip it. So in other case, we this arc contains this character, and then we can link it. So then we are just going to do transitions, and we just save from. So basically, we need to save something like this. So the transition index. Let's call it table index. I have only one real table here. So, and I give it the state. So the arc, the origin, I also give character, and I link. So let's say, let's do this a little bit cleaner. So origin is basically this, and the target is this. Now I can just say this. So of course I have to implement this method, and this method should be easy. So it returns a index. Returns a index, and it give it a state. Sorry, state is what? State is just a unsigned thing. So I'm just going to static assert. Can I somehow check if types are the same? Ah, yeah. Okay. So state same as new32. Wired for table index. So basically, just asserting that those types are the same, since table index can't see my type alias. So I'm just using new32 here, and I'm asserting the other, so the relation of the types here. So in the character, I think I can safely say that this is a U8. So this compiles now. Now, of course, I have to do this mapping. So if I have this map, so let's say we are in the zeros state, then the index to map from a two-dimensional index, basically you start with the 0th index, then the first, then the second, and so on. And then the first index of the next row is basically the width of this element. So to calculate this index, you're just going to I think the character plus the state times 56. Or state times 6, and I have a constant for this called char count. Let's X for this. Times char count. So this should be the index. So now I have this mapping, and I'm moving it into my table, and to answer which states comes next, I'm just going to look it up. Transitions, table index, state, and C. This should be it. And I think I should repeat this assertion every time where I call table index. So, okay. Now we should have a table. Let's see if our creation actually works. So let's set a breakpoint and see what happens. So I think we're already calling this. So let's just run it and see what happens. So we have a DFA. Let's see if we find the start state, error state, and this is, I think those are actually correct. So by construction, the first state is almost always 0, and in this example we are testing, we ran this on a previous video, the error state gets the ID 1. So this worked. So I think we have 19 states that could be. This is realistic. We have 256 characters. Then we have 4,864 transitions. This should be fine by me. We are allocating enough space for the corresponding tables. And I think we should now see that this worked. So our transitions, there's enough space. Yeah, so our list uses 2's complement, but I think this works. And the memory is uninitialized. So here we are overwriting memory. Should we do this here as well? So let's always do always state. So I think I just move this here. Just call this once. So then I have the index. And in this case, I'm overwriting this, but I'm defaulting this to error state, I think. No, error state is a local method, local field, so we're just going to use this. So let's actually rerun. Oh, using the wrong index. Using it wrong here. Well, so derp, getting tired. Oh. Let's see. We have index, we default to error state, which is 1. But we already crash. List out of bounds. I know. So basically, allocated enough memory, but I think we have to add. So this is stupid. Let's fix this quickly. So for I is 0, I less than transition count. So let's initialize, let's put the value there. So let's initialize this one with the error states. Let's do it here. And now for this one, I think we're defaulting to this. So I'm just writing this a little bit different. So accepting, and here we are going to state. So we initialize each transition to reach the error state, and for the accepting states, for each state we remember it as non-accepting basically, and we say we reach if this state would accept with the error token type, so with the error token. So we're basically setting the list. Yeah, so now I can rewrite this again. So this we don't have to do unless we get here. So inline this index again. Okay, so we initialized it, and of course we don't have to set this then. So since we're initializing it here, we don't have to initialize it here and here. So at the beginning of the list. Yeah, so of course that was previously also the problem. I can't access with I since we didn't add a value. So let's just add it here as well. So this is what I try to do. So now we should actually be able to access the element in the list corresponding. So yeah, so now we can access the list. So I'm not going to iterate through all of the cases. Let's see what we get back. We get back an scanner, which has a lot of transitions. Some of them are set, some of them won't, and list of accepting states. So for each state, we have 19 states. We should remember if we are accepting. So if the 0 state is not accepting, so it shows a -1 here. So looks okay. We don't see all the values yet. So let's actually set a breakpoint here, and let's run. Oh well, I said previously that our problem was the reading the file, but this is actually not the case. We get here immediately. So then let's just run it and see how long it takes to scan using the table-driven scanner driver. So table-driven scanner driver. Somehow duplicate. Last time we did a whole minute. Now we just seconds. Or what is it like? Oh well, I shouldn't have opened it. So like a little more over 1 million lines. Well, how many characters? Well, 32 million characters. Yeah, so I think this is great, but of course this operation needs a lot more time. So a lot more time. I think we should always use the table-driven, the table-based implementation. So table-driven scanner driver. So can we do this even faster? Or maybe let's just remember which time we saw. Of course, I'm just running it once. Now I could have tested it in a loop like 10, 20 times, but I think so. Let's start with this one first. So those are 2 changes. Let's start by adding the error state method. the error state getter. Introduce if a automaton error state. This method returns error state. Error state or null pointer if none exists. So I think this actually I won't keep this change. So stopwatch. So I haven't pushed my last commit yet. Just going to amend it. What did we do here? So we reduced the token index to signed 32-bit integers. So then we introduced an enumeration for the special token types. For special token types. And then we added the table-driven scanner driver. Table-driven scanner driver, yeah, well. Table scanner driver. Okay. This class implements a table-driven version of scanner driver. Okay, so let's see if we can actually speed it up even more. So what happens? Move this method in line. So do this. So let's move this helper method in line first. So then, of course, use type alias state here, and then I can remove the static assert. So and then this only is a one-liner basically. Try it out. Is it even faster now? So let's run it. Well, a little bit faster, but not much. This could also be just some variation since yeah, well, since they were two separate runs, but now it's lower. So I think it's just a variation. So yeah, it's always slower. Okay, sure. So and I don't really like that the table creation and the table access they are scattered throughout the files. So, and should I think I will remove this comment. It was just during sketching out of this API. Well, but why is this one marked as not used? It is used. It is used here. Or doesn't it use return? I think this doesn't this also use the constructor? Well, now the warning goes away. But I don't want to use a brace initializer list. I want to explicitly call the constructor. C++. Why are you so mad at me? In this case, well. Oh, and of course, I think I will just end this. So I moved this inline and moved those comments. So yeah, sure. Let's just amend it. Now, do we actually need our file draft? I am keeping it around, but I don't really think we need it. So now we did our table-based scanner driver. Now, well, we could minimize it, but I think I will just ignore this one. And better error reporting. Yeah, well. Also, we can generate one. So let's put this at the appropriate places. And also, I remove this one. Yeah. So don't know if this is actually faster. So this one is a scanner driver which only works on a simulative level, but maybe this is just fine. So we could also so currently we want to create a table scanner driver. We always need an automaton, but I don't want to construct an automaton my program all the time. Maybe just during language development later. I would like to strip out the automaton creation code and just keep the but still keep the scanner. So this is unnecessary work for our dear computer. But yeah, so maybe you can use this instance to create a class or a lightweight representation of this data without the need to use this automaton. So maybe let's put it here. Introduce another constructor not requiring like this. No, without the e. Not requiring a automaton. So I don't know how this could work. So I basically need those pieces of data. Maybe I can just also drop the list in here. So then I can just, oh, sorry, I have to sneeze. So because we could also think of that this class just accepts a big array. So for example, like this. So instead of just passing in the DFA, we are just giving it so we give it the start state, the error state, and then just a big list of what was the first parameter. So the transitions, for example. So what are those? Those are currently they are what? I lost it. Yeah. So our transitions are states. States is the use. Why I'm always saying use. Why? Yeah. Well, this is not U64, and this is also not U63. 32. So of course we could also do something like this. So transitions. And this is just a big array of values. And well, this gets generated, and we just pass this in. And also a list of what have. Well, we also have the token type. So yeah, maybe I'm not sure if I would like to explore this. Well, it should not be that hard. Just got to generate 4 values. So how could this look like? Let's say for this constructor, let's just sketch it out. Maybe we will just do it this now. So, and I'm thinking we just, but how can we use this? Or can I somehow not allocate any memory? So here I'm passing in a list. We have to free the memory. But the other case, we don't have to free it, since it uses static memory. So can I somehow can I somehow abstract this out? The behavior when destructed. Can this be somehow without any weird hacks? Can just put this into a union, for example. Just the one, yeah, let's, I don't like this. How do you call a read-only list? This is the most important question. Let's call it sequence. So I'm thinking of doing following. But then we have to always dispatch. Maybe we just create another class. But I would love those two classes could share the implementation. So this one can create a scanner driver. A table scanner driver. But we factor the table out. We abstract our key allocation then. Good. But also, well, I don't want to dispatch every time. So let's see, for example, we could of course just invent a constructor which, how could we, which takes in a instance of something. Let's call this static table. Maybe let's just define this here. No, I don't like this. So can I somehow put this into two separate classes? So can I somehow, so this of course is just a list which can grow. It can grow, you can clear it, things like this. But I would like to have a iterator, a list-like API for a read-only view of, or read-only view, similarly like a string view. I would like to have a list view, let's just call it list view. It's just a view of a list, an immutable view of a list. And then Does this help us? So I'm just designing the API in my head. I would like to share the code, the scanner driver implementation, but I don't want dispatch based on a flag. For example, I could also do something like this. I could put this all in a union, for example, a union of structs. And why is this so beautiful? And let's call this one like dynamic, for example. Oh, well, it doesn't work. It doesn't matter. So this one, in this case, we are allocating, and if we use another case, we use read-only memory. So this class only reads, but so in this way we could differentiate, abstract our destruction of this list. But well, then I had to dispatch every method based on a flag, which we have to remember. So like static memory, and then I had to, for example, if we use static memory, then we use different where we then have a transitions pointer and a count, example, count field. In this case, I would use this, but I don't like this. So I'm thinking of doing the following instead. So basically, I would like to experiment with this to do now, since I like the idea of just generating some code, pasting it somewhere to your project, yeah, and then we just be able to reuse it and import it as a generated artifact. So this one, so maybe let's first of all begin with a list-like interface, just for read-only, a wrapper for read-only memory. So let's do this first. So I'm just copying my list class and calling it list view. So list view, list view iterator. So this is just, can't I just reuse list? So list view. View has no capacity. Just gets a pointer and a size. So, and copying is trivial, moving is trivial. I'm not going to define any of this. No destructor, this is no problem. So size, we just return, so we don't have a capacity, we won't have those methods, we won't have clear, have this, no, we won't have this, well, can keep the contains method, we won't have this, and just remember the size of our list. So in the constructor, oh well, this iterator. So we won't have this, we won't have this, we won't have this. Contains stays, add goes away. Index access, fine. Index access, copy here, everything is gone. So where's the constructor? List view. I didn't define it. Data and size is so. Just remembering the pointers we get passed. And the iterator methods just return a list view iterator. Okay, fine. So does this actually make sense? So list and list view. Okay, so now we have a list view. So I'm thinking that this just returns a data and a size. Okay. And so now on list, I think we can just always use list view iterator. So let's include core types, also core list view. So let's remove the list iterator. I think I should. So list view. I'm just reusing list view iterator. For now, wouldn't really make any difference. So and then I'm adding a method called toView or something. So and I'm just returning list with mData and mSize. Do I have access to data with a getter? Oh, let's just keep it that way. So then I can return a list view, same data. It should be fine. So this is then just a temporary view. I think I can implement those in terms of view. Begin. Okay. Okay, sure. It will not be the fastest, but I don't care. So now I should be able to do the following thing. So the table scanner driver, I think I'm converting this to an abstract class. So let's change this to a list view instead. And I forgot to import the name. the symbol. So, and then of course the constructor has to change. Also in the transitions, the accepting list views. And in this case, we're just accepting as list views as well. So this basically this constructor expects correctness. So let's call this one static scanner driver, since it works with static memory. So we're working on this. Let's just do it. Static scanner. No, static table driver. Oh. Okay. And let's just copy paste this. Let's rename this in EFA table scanner driver. So just to differentiate that this one creates a table out of our EFA. So names are far from being perfect, but fine for now. So this is the EFA table scanner driver. So, and basically I have to move some code around. So this method I will move to the other class. This one. Oh well, I have it here already since I copy pasted the file. So let's change the code around a little bit. So the static table scanner driver so basically this one is workhorse. And how do I construct such a thing? I construct it by just giving it this. But how do we do this? Maybe let's create a class which just encapsulates those values. Let's just call it static table and put it in the sigil namespace. Just get those members. So static table, and then can I do that? Just copy this, paste here. Well, it's not perfect, but so let's create accessors. And let's also implement the constructor. But now I need those types public. Think that through. So maybe we go back. So those types are private, but they don't really have to. Let's also introduce a class which I'm calling a header, which I'm calling types inside of sigil. So we're just going to include core types, then just where is it? Scanner driver. So those are, yes, where are they? Here are they. Here they are. So we're just moving them in this types header. Then I can include this one here. So sigil types. Now the compile errors should go away. And now I'm also able to include them here. So include sigil types. Also add this to our build. So static table. I move them to a namespace. So now I can also include for this view. And we should already be. So of course, now I can regenerate the constructor, get better types. So error state, transitions, transition, and accepting. Should I SD move it? Or will the compiler cry since they are trivially copyable? Yeah, so, but this also defeats the purposes of our string view. So let's keep it this way then. So we have a static table. and I think those want to be no discard, so well, this doesn't work anymore. So I broken the list view iteration for each method on lists. Should have compiled earlier. So this is just for for storing them here. Why doesn't it work? List view. What did I break? Oh, list. Sorry, list view. This then what? Oh, let's give it a type. Does this help? Invalid conversion. Wired from here. Okay. So since link gets inlined, so the list to view probably tries this line, but I think the constructor of list view gets inlined here. To be trivial. I think this is why the error is a bit abstract here. So, and trying to view a list with a arena block. In this case, I have a list view of blocks, which requires pointers to blocks. And why can't convert const to non-const since the constructor is non-const? Ah, I'm so dumb. So this problem, we're also requiring a non-const overload. Because I think we can just so I'm thinking we can just introduce another one. Just cheat and const cast. And in this case, the constructor is correct. In this case, we're just delegating to list view, but we const cast to the size. Now it builds again. Now it doesn't build again since dates are now global. And so is token type. So cool. Now, to create a static table in a driver, we're just passing it a static table. And now, this is what I wanted to do actually. I would like to have a static create function that takes a static table and just returns this. So internally, we're unpacking this and just pointing to this. And we don't copy anything. So the static table is just a reference bundle of data that describe a scanner driver that works with some memory. So now we fix everything else. So static table. And now we're just unpacking everything. Don't need to move anything. We're working with string views. So can I now some IDE magic? Yeah. Okay, just on what? Why does it change everything to fine? So now the create method is a lot easier. So I think my idea is in this case I don't want to have a create method. Just using this as a public constructor. So the idea is if you get a static table, everything is fine. Of course, you can craft one a malicious value by hand, but then I won't care. So in this case, I'm just going to remove the creation code. This class works once it gets a static table instance. So I think this class should be fine. Now, if a scanner driver oh, this is the incorrect one. The DFA table thingy. So let's rename this class DFA table scanner driver. That's this everywhere. So, and I think this one internally just does the following. So I'm just reusing the static thingy. I'm just creating an instance and I'm just delegating to every call to this. So start state, no, accepting, token, state, arrow state, this accepting state, next state of state and C. Also the start state, so return underlying start state and also return M underlying arrow state. So this is just a class that uses a static instance, but also remembers the lists. So we have a list of, how was this? Okay, so those lists, so the DFA scanner thingy allocates those lists, and it allocates them really, so no static memory for those. And basically just giving this. So, and it keeps the lists around, and when this class gets destroyed, then also the memory gets freed. So, but this class is implemented in a way that the memory doesn't care where the memory comes from. So, and create such a thing, such an abomination. Also, I have to change the creation code as well. And the constructor, sure. So the constructor now get a list, a static scanner driver, lists, well, on file here, lists and static scanner driver. So now does this work now? I moved to the wrong file. No, it's the correct file, but in this class, the names are wrong. So the static scanner driver thing now called a scanner driver. Yeah, so list, and table, static table scanner driver. So and this one is still the static table scanner driver. Oh. And here, this thing, I'm just moving in the values, and I'm just constructing a static table scanner driver, the underlying driver. And how is this one constructed? Using a static table, and the static table is constructed like this. Static table gets a start state, the error state, and two views. It gets the transitions view and the accepting view. And this one gets this one gets this. So I hope this still works. Why is this private with the context? Not make this private. So let's move this so sure my test code doesn't work, and to create a new table scanner driver. This is now DFA table scanner driver dot create. So does it still run or does it crash? So, and now what this allows me, this step, I'm creating the table-based scanner driver out of my, it gets really slow suddenly. 3 seconds worse than before. So I'm using this class to create it out of my DFA, and then I'm thinking to add a method that just emits the static table. Well, it's a little bit better now. So it is not a strict science here, so but doesn't really matter. So and now I would like to do something like this. So the scanner, I would like to get the static table out of this. So static table, static table, static table. So and how do I do this? I'm just ask underlying to get the static table. Since we have everything we need to know. So let's do this. So static table, static table. So in the static table, we give a start state, we give it the error state, and give it the conditions, and we give it the accepting state. The if a scanner thing, and now just delegate underlying dot table. So, and those methods I'm also going to define publicly. Great method. And those lists are just used for keeping the memory, and they get destroyed, class gets destroyed. Okay, sure. So now, what can we do now? Now we can get the static table, and I'm thinking to create a way to print this. So just debug log it, maybe. So let's define a formatter. So template, type name, well, no, like this, class. Also a template specialization for formatter. And I'm just giving it this. Or is formatter also already known? No, it is not. So let's include core formatter. So formatter requires a public static void format function, which accepts a string builder as a first argument and a type, an instance of this class as a second type, as a second value. Then I'm going to implement it. So let's include, well, core formatting. There are some helpers. So now I would like to print it in a way that I can just repaste it back into C++. So let's say I would like to print one single expression. So let's say I would like to have the following style. I would like to have sigil static table, open parentheses, then the state. So like, for example, 0, 1, and then let's just have a big list. So I need a string view, a list view, of course. Let's explicitly prefix everything. No, not string, the state. And well, then some values. And then core list view token type. And then another list. So like this. Then just closing parentheses. Let's just begin with this style first. So okay, let's do it. I also want to format this. Well, I can do this in the second step. So let's just begin. So formatting. Format into string builder. And let's just start with this. So let's do it line by line. First of all, I would like to print this followed by the start state. So table dot start state, comma, then print a comma, then print table dot error state, then print a comma, then maybe let's call a helper method like format list view of table dot accept. No, first the transitions, then print another comma, then we print the accepting states, no comma, but a closing parentheses. So let's do it like this. And then to format a list view, let's also pass in the element type. So state, for example, here open name, open type, of course. So format list view. A list accepts a list view of type T and a string view of type element type name. And it will be templatized. So like this. And I'm missing the return type. So now this should compile. Let's try it. So, and to emit a list view, just going to do the following. Let's start similar like here. Start with this. Of course it needs a builder. String builder. So instead of this, we just print core list view of element type name. So, and at the end, we print a closing parenthesis. And the list view gets a big list and a count, basically. So then let's try to print the elements inline here, and let's print the count separately. So view.size, and then just the elements. So let's say we are the first one, and if we are the first one, we are just going to print this value, but we are not the first, so if not first, we print a comma, and then we reset the first flag. We are not the first anymore, and then we can just print the element. So element, no, element. So let's try this. Let's try this out. So in our menu, we already call debug log of our static scanner thing. Let's just skip the file and let's just run it and see if it actually prints anything. Okay, let's copy and try it out. So this creates a DFA table scanner driver. Let's uncomment this code. Let's comment this out. Let's do the scanner static blah 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 like this. Let's just paste the thing we copied. How does it look like? Well, it's just beautiful. Wow, wow. This is really ugly. I think I have to print it as sigil state. So let's just change our types to sigil state and sigil token type. It's a rerun. Well, didn't think this through. I think we might be able to compress this table, but let's just don't do this right now. So so let's rerun. So where does this constructor end? Parentheses. Nowhere. But I'm providing two values, don't I? How do I do this? I think I can't do this that way. But what if I just say that this is a array of can I do this? No, I can't. But I know the count, so can I do this? No, can't. Not cool. It would be so cool if I could construct those inline. So then it can't be a single expression, or can it? Let's can I just put this as a separate variable, like sigil open type accepting? Can I just do this? This now, no, I now have to specify that this is an array. But this should work. Test elements in scalar initializer. Well, this works. So now this works. Perfect. And if can I now give this to my list view? Seems like it works. So let's also remember sigil. Well, how were they called? State? Yeah. Let's paste everything here and let's just format and hope that nothing breaks. Also, do this. So, states. But does this work? Now, can I just rename scanner and does that still work? Of course, this is a static table, but I can now construct a static thingy from this. So this is called scanner, and this is called should be called static table well table. And this is should be fine now. Of course, let's not print the. Let's just print the table again. Well, I'm also still returning. So does this continue to work? Does it still work? It works. And for this scanner, we don't need the what do I want to say? We don't need the grammar anymore. So this is the last point where we use the grammar. So from here on, we just use the pre-baked table. And every time we see a 1 here, it transitions to the error state. We might be able to do something else. Since I think this table is pretty sparse, so maybe we can do some compression to compress this. But I think I'm doing this at a different point in time. So we can try to compress the table, and didn't I also do the minimization? Yeah, so let's minimize DFA, but also compress table. Compress table. It looks pretty fast to me. I don't know how we could, but I think I will keep toying with this. So because you don't really need to store all the ones, but I don't know if we would then. But I would like to have it as quick as possible. So maybe we can create in a fast. I don't really know how to do this. No idea yet, but great thing and a great thing to play with. So, so what did we do today? We worked on a table-driven implementation of our scanner driver. And first of all, we introduced a class. So we turned our DFA into a table. Surprisingly less small amount of code that you require. And then I decided to split this class into two. First implementation just takes a view of the memory and is able to basically implements the algorithm. This class is the workhorse, and this other class just constructs the table and then creates instance of the underlying static table inner driver, and then we refactored. During this, we also factored out the class static table, which is just the essential parts, basically, just a view of data that is required to drive this class, basically. And well, we have a print function that allows us to print a single expression, or not quite a expression, but close enough for now. And yeah, basically, basically now you have a way to construct a scanner driver easily. You can easily create a scanner driver that doesn't require the automaton anymore and these scanner specification. So you can just bake this into your code of this horribleness, and hide it somewhere, and then you have a scanner that uses this pre-baked table to basically use to scan your code. So maybe we will just do this as a little cleanup the next time. I have to wrap up now, unfortunately. So let's create a to-do and let's call it and we create a single expression. And we put this a single expression. So and this is I think what we're going to do next, and maybe we will look at some table compression or automaton minimization. But not sure, maybe we will use this to do something productive with it. I have not really decided. Thank you all for watching. I hope my mumbling somewhat entertaining to you, and yeah, have a great day. See you next time. Bye.